I'm back again. Hope you had a great time and learnt a lot from Dr. Isabel. So now, in this section, we will talk about the Golgi tendon reflex. Do you know how the tendon reflex prevents excessive tension on the muscle? So, after understanding Golgi tendon reflex, we will understand the tendon reflex prevents excessive tension on the muscle. This is Golgi tendon organ. This is muscle fiber. This is muscle. This is spinal cord. So, Golgi tendon organ helps control muscle tension. The Golgi tendon organ is an encapsulated sensory receptor through which muscle tendon fibers pass. Now, let's understand Golgi tendon reflex. Excessive tension of the muscle stimulates sensory receptors in the Golgi tendon organ. Signals from the receptors are transmitted through a sensory afferent nerve fiber that excites an inhibitory interneuron in the spinal cord, inhibiting anterior motor neuron activity, causing muscle relaxation, and protecting the muscle against excessive tension. Thus, the major difference in excitation of the Golgi tendon organ versus the muscle spindle is that the spindle detects muscle length and changes in muscle length, whereas the tendon organ detects muscle tension as reflected by the tension in itself. Now, let's discuss transmission of impulses from the tendon organ into the central nervous system. Signals from the tendon organ are transmitted through large, rapidly conducting type 1b nerve fibers that are average 16 micrometers in diameter, only slightly smaller than those from the primary endings of the muscle spindle. These fibers, like those from the primary spindle endings, transmit signals into local areas of the cord, and after synapsing in a dorsal horn of the cord through long fiber pathways such as the spinocerebellar tracts into the cerebellum, and through still other tracts to the cerebral cortex. In the beginning of this video, I asked you that how the tendon reflex prevents excessive tension on the muscle. Well, when the Golgi tendon organs of a muscle tendon are stimulated by increased tension in the connecting muscle, signals are transmitted to the spinal cord to cause reflex effects in the respective muscle. This reflex is entirely inhibitory. Thus, this reflex provides a negative feedback mechanism that prevents the development of too much tension on the muscle. When tension on the muscle, and therefore on the tendon, becomes extreme, the inhibitory effect from the tendon organ can be so great that it leads to a sudden reaction in the spinal cord that causes instantaneous relaxation of the entire muscle. This effect is called the lengthening reaction. It is probably a protective mechanism to prevent tearing of the muscle or avulsion of the tendon from its attachments to the bone. Now, let's discuss the possible role of the tendon reflex to equalize contractile force among the muscle fibers. Another likely function of the Golgi tendon reflex is to equalize contractile forces of the separate muscle fibers. That is, the fibers that exert excess tension become inhibited by the reflex, whereas those that exert too little tension become more excited because of the absence of reflex inhibition. This phenomenon spreads the muscle load over all the fibers and prevents damage in isolated areas of a muscle where small numbers of fibers might be overloaded. Moving forward, to understand the function of the muscle spindles and Golgi tendon organs in motor control by higher levels of the brain. Although we have emphasized the function of the muscle spindles and Golgi tendon organs in spinal cord control of motor function, these two sensory organs also apprise the higher motor control centers of instantaneous changes taking place in the muscles. For instance, the dorsal spinocerebellar tracts carry instantaneous information from the muscle spindles and the Golgi tendon organs directly to the cerebellum at conduction velocities approaching 120 meters per second. The most rapid conduction anywhere in the brain or spinal cord. Additional pathways transmit similar information into the reticular regions of the brainstem, and, to a lesser extent, all the way to the motor areas of the cerebral cortex. This was all about this section. In our next section, we will talk about the flexor withdrawal reflex.
Explore our extensive library of over 1,800 video lectures to learn about a wide range of topics. Only on sqadia.com.